Hi guys, it's me UBprogrammer and welcome to the lecture 3 of OS series, and this is the continuation of the hardware protection topic which we are studying, which is the result of multiple users are using the same hardware for executing different program at the same time. So you can sense our tension here, right? Single hardware want to do many stuff, and there should be some time of protocols followed, right? So these are the topics, and the memory protection uh, is being concerned here. So you got memory in your computer, and these memories are allocated to the executable programs or the process or the job, right? And every process has this address space in the memory, and which is his own or the allocated memory, right, for the specific process, and preventing a process to take any other space which is not his, right, or it's like I'm calling it a living being, but you can like say, and then its other than its allotted memory space is the memory protection. So you want to protect the memory somehow, right? So process can only deal with the memory which has been allocated to itself. So every process has two registers in the memory, which is uh, you can say the base register and the limit register. So when a process is created, these registers are automatically created, and the CPU allocate a chunk of memory to this process by comparing the base register, like base register is the smallest memory address which can be allocated, and the limit register is the size of that process, right? So CPU will make sure the allocated space will be greater than or equal to the base register and less than the limit, right? Because you don't want to allocate more memory to a process than its size, right? And then you got the CPU protection, and this is the fourth topic, I think, of the hardware protection. And because multiple processes are running, so they all want CPU to listen to them, right? But CPU will decide it on the some type of priority protocols, obviously, and this will be done by a process called CPU scheduling, which is the functionality of OS we studied in lecture 2, right? So in this technique, CPU scheduling will use the timer and internal clock system to generate an interrupt we have also studied uh, for the CPU to switch it to the other process, right? And we will study the OS components. uh, so this is the first component, process management, and the process is an executable program. We have already seen that. The main memory management, the main memory is like your RAM, where when you load a program, so it is loaded in the main memory, right? It is volatile. If power goes off, your program will be wiped out, right? You got disk storage management, which is your ROM, read only memory, and your input output systems or devices, so it will be managed by these OS. So all of these are the components. So file management, Obviously you want to store files, retrieve them, load them, see them whenever you want. So all of these, or maybe protect them somehow. So all of these are the OS components. Protection system management. So a user want to protect his data. And then the network management and the CLI, command line interface shell management. So you don't want user with uh, with some limitations to execute commands in the shell, which are for the super user, right, or the administrator. Now let's talk about the services of the operating system. So there are two type of services which OS deal with. One is for the users, and you can see the program execution. You want to use the Microsoft Word, you want to open it, so that program execution will be done by the OS as a service for you, right? Then input output operation, you want to print something, that will also be done by the OS. The file system management, inter-process communication. So if you are running a program, now let's see in the context of the programming. So you are writing two programs, and these two programs has to talk between them during execution. So you can do it by the inter-process communication. Then there is error detection and handling. So if program goes into some error, so the you can say the trap will be generated, and some part of OS, some code of OS will be executed in that case. Then there are services for the OS, like resource management, so hardware protection we have seen. So that resources which are the hardware of your computer system, how they are managed by the processes. So OS as a service will do it for you. Accounting of usage, so which process is using how much of the resource, so you have to keep an account for it. And the protection, obviously you want one process to do only things which is allowed for that process, right? Then there is a really important topic, OS kernel, because kernel is the part of the OS which has all the code, and all the real work which OS do is do by the help of kernel, right? So where is kernel in the computer system? So in the CS computer system, we got hardware, then OS kernel, then OS API, and AUI. These are the application user interface, and we got application and user. So whenever a system call occurs, system call is obviously we have seen that if execution is being done in the user mode, and a process want to execute some stuff which is only allowed in the kernel mode, system call will occur. So a user have to do some system call, which is like open a file for me. This is the system call, right? So a system call will be occur, and control goes to kernel. So control will be goes to the kernel mode or the monitor mode. Okay, and the some type of system call, like process control, file management, device management, information maintenance, and communications. So these are all the system call you can generate as a user, right? So you want to control a process, do something with your files, and do something the attached device in your system, right? The execution of system call, let's see that. Like, you have the program executed, which is process, so it will generate a library call which will then trigger the system call. Then kernel, the control goes to the kernel, and the kernel will see what code should be executed. So there is a thing called dispatch table, which has the system call ID and their respected code which will be executed. So a system call has an special ID, every system call, right? Okay, that's it for the lecture 3, and we will start the lecture 4 in the next video. Thanks for watching.